Attention mounts. Someone willing to put himself or herself out there. Waiting for Sophie to tell me the answer. Adriana?
I have a question.
Oh.
About my calculator.
Oh, yes. Pardon? Oh. So it looks like you had a negative under the radical. Be my guess. Okay, see what you. Alright, so. 200. So that's. Oh, no, that's 40,000. That. Oh, when you did divided by 2, that it divided by 2 and then it multiplied by 78.4. You need parentheses around the 2 and the 78.4. So it multiplies it for it. All right, do we have anyone with answers yet?
For the positive 2.06 and 0.484 for the negative.
2.06 and 0.484. So they're both positives?
No. When you subtract the square root value, it's 0.484. And then when you add, it's 2
Right.
answers.
Okay, but neither of them are negative. They're both positives.
Yes.
Okay, yeah, that's what I meant.
Okay.
But thank you for your clarification. All right, so anyone else get these same 2 answers? Right here. Okay, I'm guessing you did not.
Like, where does those two come from? Which
From,
one?
if you solve the quadratic formula, right, use the quadratic formula to solve the quadratic equation. Those are the 2 answers Chris got.
On that 125?
Yeah, on that one problem. Because quadratics typically have 2 solutions.
I'm just picking on the third one. Third one up.
This one?
Yeah, I was like, wait, like those times.
And this is what we're solving. We're just, I didn't feel like writing tan theta over and over again, so I used the letter Q instead.
Can you help me with my calculator? It's happened last week, but every time I put anything over here, it gives me the wrong real answer.
All right, backing up. So 200 squared minus 4 times 7, and what's the last number, do you remember? Yeah, it's not 200. The last one is 38.4. There we go.
Thank you.
All right, anyone else have different answers?
Notice that's wrong.
Oh.
I put 78.4 for the C value.
Okay, what do you have?
I got 2.34
2.34,
and 0.209.
0.209. Okay, Sophie backed it up. Still not. Well, we have 2 people voting for this one.
And so, hold on, so that, is like that.
What, the tangent of, we don't know what the angle is, but the tangent of that angle is equal to this or this. Pardon? See?
Hold on, I don't want to say it out loud, but I'm gonna say it.
Yeah, that's, I
You got 3 people now with this. Feel like the groundswell.
You doing the same thing?
We got 4, we're up to 4.
Oh, no, never mind.
5, 6. I'm gonna assume that is correct at this point. 7. And a couple of people very confused at the moment. Why did they not able to get it? Let's finish the problem, and then after class, if you have a little bit of time, we can try to figure out where the glitch was. All right, so recognize we have two different answers here. Even if one had been negative, it still would have been a legitimate answer. Now, the tangent of theta is sine over cosine. On a unit circle, it would be, in what quadrants? This is the first quadrant, second quadrant, third quadrant, fourth quadrant. Why is it counterclockwise? Because that's what the math people did. In which quadrant is the tangent positive? Yeah, so tangent's positive here, and tangent's positive here. Tangent's negative, obviously, in the other two. So when we get an answer, when we do the arctangent, the calculator, if it's positive, is going to give you a first quadrant angle. Occasionally you might think, wait a second, is it a third quadrant angle? There are times in which you do want the third quadrant. In this case, not really, because it's being shot either the first or the fourth quadrant. If it had been negative, recognize there's a second and fourth quadrant angle, which will give you the same tangent for a negative value, but we would want the fourth quadrant. If we had one negative, that meant that one of the solutions would be that it was being shot downwards. There's nothing wrong with it being shot downwards. Just in this particular case, it doesn't have to work out that way. So theta is the arctan of 2.34 and the arctan of 0.209. So 0.25, so this is about 10 degrees. And I guess that's about 80 degrees. We can fine tune that one a little bit better, about 10.8 and 79.2.
I got 11.8 for that.
11.8?
Yeah.
And for the other one, it's 66.86.
66.86. All right. Which means that it's being shot at a 66.8 degree angle. If it shoots up like that, it's going to go up and then it's going to land here. Or it's being shot at a much shallower angle, almost horizontal, it's being shot like this, and it's going to hit in the same spot. There are two solutions.
I have a question.
Yes.
So what I was trying to say was, couldn't you plug that in the graph and trace it?
All right, another way of solving these problems, and this comes down to how accurate your calculator is. At this point right here, potentially you could plug these two into a graphing calculator and just see where they meet. The trouble with that is I've had students do it that way, and somehow they can't identify where the point they meet is. And I don't know whether it's they don't know how to use their calculator, or the calculator's not precise enough. So the upside is, yes, if you can do it graphically using your calculator and you know how to do that correctly, go for it. The downside is, if you don't do it correctly, there's pretty much no partial credit, because it goes from here to an answer, and there's this whole step that's missing. You figure out the problem?
Yeah, there's just.
Okay.
So it's that, not that.
This comes from that. These are these two equations right here are the equations we started with. This is what we were using to solve for theta.
Okay, and then to finalize the answer to get negative 40 and the 2.
I mean, ultimately, we're solving for theta.
Yeah. No, I know. I'm saying the white in the graph. We put the two bottom ones, right?
Oh, I would actually, if you're gonna plot that, and then that and that, I'm not quite sure how you do these like 4 graphs. I would add 40 to both sides and let y equal this, and then y equal to that, subtracting 200 from both sides. I don't use the graphing aspect of it, so, and I don't know how to do the graphing aspect on your calculators. It's just not a path I go down, so. But at least you know what the answers are now, so you can if you want, you can test it out
Yeah.
at home if need be. Right, questions? All right, and I think I have some exciting news. I do. Very exciting news. Not only are we dealing with chapter 3, so we can figure out when the tests in the master set are, but we can also talk about the first test, of when that is. That's right. I see one person to plot, and I assume the rest of you are plotting in your head. So today is the 30th. Let's go with the quiz. The quiz on chapter 3 is due a week from today. Let's do it a week from today. Quiz 3. So that'll be February 6th. The master set for chapter 3. Let's say Tuesday, February 11th. And test 1A. Let's make February 18th. All right, so what we have here is, so 2-6, the quiz, the homework quiz on chapter 3. That is Thursday of next week. And then 2-11, we have the master set for 3, that's Tuesday. And then,
211 is Wednesday.
pardon?
211 is Wednesday.
Good.
It's a Tuesday.
Oh, I'm on my calendar.
You're in 2019?
February?
I'm in March. I'm bad.
Again, you're thinking ahead to the future, come on back.
I'm bad.
And then 2-18, test 1A. All right, so a couple comments here. First, this is my proposal. Anyone got a counter proposal, bring the test in sooner, or I don't want to make it drag out too long because we are going to cover material for the second test in the interim. But unless if there's a huge groundswell to push it off, we can push it off, but I don't think that would benefit you personally.
Did you just make the test and the quiz on the same day?
Test and the quiz on the same day? I have done that before.
That sounds terrible.
It was quiz, 2 tests, and course evaluation all on the same day. They did not gig me as much as I thought, considering all the stuff I got crammed in on that day. All right, assuming that I'm going to reject the quiz and test all on the same day idea, then I guess this is what we're going with. A couple comments. There is, on Tuesday the 4th, you have a lab, and that lab will be due the 11th. We'll do a lab on the 11th. Because we are not doing lab on the 18th, the lab that you do on the 11th is actually due the week after the test. So, I mean, if you have the lab ready the day of the test, that's fine, but the lab that you're doing on the 11th is due on, I guess, the 25th. Also, and we have plenty of time. I'm gonna cover more material after I'm done with this, so if you're thinking about it's time to pack up, it's not. Test 1A, I think I commented on this before, but I want to reiterate or say it for the first time if I did it with a different class. Originally, the first test would have been the equivalent of chapters 1 or 2 through 5 or 6. And that seemed to be a little bit too much. And so I've broken it down into, thank you. I've broken it down into 2 tests now. So if you're looking at test 1, if you look at the test and it says test 1, that's covering the material from 4 or 5 different chapters, 4 or 5 chapters. If it says test 1A, if you're looking at test 1A, that will be the material that's on this. So if you're looking at a test 1, not a 1A, but a test 1, just recognize some of the problems are not appropriate for studying for what you're about to do. And then test 1B would cover the other, what used to be the second half of test 1. Test 1A, test 1B count as 2 tests. It's not one test, just in terms of labeling. That's the way I labeled it. Other questions at the moment? All right, I want to build off this energy, the excitement. I know, you got a test coming up and you're thinking, well, that's a long way away. Surely we can do more material.
Yeah.
Yes, we can. Chapter 4. And not sure I could have picked a word marker. Oh, yes, I could have picked one of those.
The ones up there. Okay.
It's not capitalized for any particular reason. All right, so what is a force? All right, there we go. Everyone hear what Ben just said?
Push or pull.
That is the best working definition, and that's what we're going to go with. There is a formal definition of it, which to me is so incredibly vague, it's worthless, but push or pull really works. The formal definition, see if I can do it with the right snotty accent. An influence which might cause acceleration. Why I decided to do snooty as a slight British accent, I don't know, but that's the way I went. I'm not sure I could do snooty in Irish, that always seems so happy. Yeah, all right, I'll worry about that later.
With French.
An influence that could cause acceleration. I don't know, I'm not sure which one's worse. Anyway, push or pull. Would you know if a force is acting on you? Is there a force acting on you?
Yes.
What force is acting on you?
Gravity. Centrifugal.
No. All right, hopefully that'll be the last time. I will use the word at some point later on, but I'm hoping you will never use the word centrifugal ever again in this course. And the reason why is that it is so badly misused. There is a time and place for it. And when we get to chapter 6, I will explain when it is, what centrifugal force actually is. But it is not the one that we really care about for the most part in this course. So it's the other one which is more important. Now, so what force is acting on you?
Gravity.
All right, I heard a number of people say gravity, and that is not exactly correct. Ben, what's the correct answer?
Force due to gravity.
Yes. Right now, otherwise known as?
Wait.
Yes, thank you. Flash back to, what, a half hour ago? All right. Any other forces acting on you? Ignore air resistance, of course. If there's a slight breeze on you, we're going to ignore that. Pardon?
The floor.
Pardon?
The floor.
You're touching the floor?
Yeah.
Are you?
My feet are.
You don't have your shoes on or off?
Well,
Or is there some Jedi thing where you don't think, your feet don't actually have to touch the floor for the floor to exert an influence on you?
I am.
Ground.
The ground? I mean earth? You're touching the earth. How's the earth, other than gravitational force, how's the earth affecting you?
Rotation.
True, it's not a force, but
Air pressure?
you keep wanting to bring air into it.
I'm.
You're that guy who wants to bring too much reality in too soon. Just why. We're ignoring the air. All right, so what happens, how do you know that there's a force of gravity acting on you? Or how do you know that you have a weight right now?
Because when you jump, you go back down.
Okay. So, but you're not jumping. Does that mean there's no weight acting on you?
We're being held down to the earth.
But you're not,
If I went
On the
limp,
earth.
I'd fall.
if
If
you,
I just like relax all my muscles, I just fall straight down.
so do you feel like there's something pulling you down? So why aren't you falling right now?
Because we're actively standing against it.
Because the ground's pushing away from us with the equal force that we're.
When you say the ground, what do you mean the ground?
Below.
As in the earth, the dirt, the carpet here,
Just
or
below.
below?
Yeah.
This generic thing called ground, which covers everything below you.
Below.
Those people in the library must be hating you right now if they're holding you up. All right, let me ask you more directly. Is the chair exerting a force on you? How do you know the chair is exerting a force on you? Because if it weren't, the force due to gravity would be much more overwhelming and you would fall. So, the chair is holding you up. I'm leaning against the wall and I'm standing on the floor. What are some forces acting on me right now?
The board and the floor. Well, anything that you touch has a equal reaction against it.
Okay, so they're exerting, and there's one other force acting on me.
Gravity.
Are we talking?
Thank you.
Oh.
Forced. Sorry.
Or weight. We can just get away with weight right now. The difference between weight and force due to gravity will, in chapter 6, that's when it really becomes more of it, where we really need to distinguish between force due to gravity and the subset called weight. But right now, force due to gravity and anything that we're working with in chapters 4 and 5, weight is good enough. If you like more words, force due to gravity. All right, so there's two forces there. There's this weight, so force due to gravity.
Is this going into energy,
Going into,
like kinetic energy and all that? No.
yeah, that's chapter 7. And so we have two symbols for that. There's F sub G, which is the generalized, or the lowercase w for weight. This is specifically weight. And weight is a specific case of F sub G. Now the force that the chair exerts on you, some textbooks just call it a support force, but we're better than that. We have a different word for it, normal force. You were right before. Again, don't know why it's capitalized, but I just did it anyway. The symbol I use for normal force is a capital Y. Because we don't use capital Y for anything else. We have 100 symbols, upper and lowercase, our alphabet and Greek alphabet. It's 100 symbols. So, yes, we'll pick something we're not using. Now, some people will do F sub n. Some will do lowercase n. Do not use uppercase n. Do not. That is reserved for something else. But I will use Y. This is a support force. Why is it called normal? Normal is a math term. And for those who've had statistics, it is not a statistics term. It's a geometric math term.
Does that have to do like with faces?
Of what faces?
Yeah, like, so it's like you have like your verts, your edges, and your faces. Does that have to do with the normals and that?
Yeah, you can connect normals to that. What's the normal for? There'd be a normal to a face.
Yeah.
Do you know what normal means though?
No, I just messed it up.
Okay. Anyone else? What the math term normal means?
Nah, I don't
Remember. Means perpendicular. So let's talk about some little rules here. All right, force due to gravity. So requirement. spell it, requirement. Force of gravity, you need two masses. All two masses have a force due to gravity acting between them. There's a force due to gravity between you and the person next to you, between you and the book, between you and anything else in the visible universe. Most of those forces are so incredibly small, we ignore them. I do not have to worry about the forces acting between me and the ceiling because it is so small compared to the major force between me and the earth. So we will ignore most of those. The one we really care about right now is the weight. And so the requirement for weight is two masses, and one of the masses is huge. And I'm putting that in quotation marks, just it's a vague term. We're talking planet size or moon size or something like that. And two masses are relatively near each other. There is a force due to gravity between me and the sun. The sun is huge, but I am not relatively close to the sun. Therefore, that is not called weight. The requirement for normal force is contact. Gravitational force does not require contact, but normal force does. Now, when you're dealing with forces, there's an important principle here, is that when you're dealing with forces, forces always come in pairs. There's not a lot of always in physics, but this is one of them. Forces always come in pairs. And each force in that pair acts on a different object in the opposite direction. Or in opposite directions. So right now the chair is pushing up on you, but you're pushing down on the chair. That's the pair we're talking about. So direction of force with respect, and with respect to is just abbreviated WRT, with respect to. The direction of the force with respect to the object. For normal force, it is perpendicular to surface. Perpendicular to surface. For force due to gravity, it is toward center of other mass. So right now, the Earth is pulling on me. The force due to gravity, my weight is acting towards the center of the Earth. Technically the center, mass of the Earth, which is close enough to the center. But I'm pulling up on the Earth too, because they come in pairs. If the Earth's pulling down on me, I'm pulling up on the Earth. And the force of gravity between me and the Earth is towards the center of me. Somewhere in there. And then direction of force with respect to its pair. The two gravitational forces, I'm being pulled towards the Earth is being pulled towards me. The two gravitational forces are always towards each other. Normal forces, the chair's pushing up on you, but you're pushing down on the chair. The normal forces are always away from each other. Questions to here? we're about to apply it, this stuff. We're about to enter into the exciting world of force diagrams. Yeah. Exciting, because the very first one that we're gonna do for our exciting force diagram is box falling. So let me draw what's going on here. I have a planet. I have a box. It's falling. Even though we're ignoring air resistance, a little streamer is there to give some indication of motion. Or it smells, one of it. This is a physical picture of what is going on. I am going to separately, now it might seem ridiculous here, it makes more sense the farther we go. What I'm gonna do is I'm gonna redraw these two objects so I can draw my arrows. So this is the physical representation. And this is where I'm gonna do my force diagram. And so now we go through, at this point we have only 2 forces, we'll eventually get up to 5, which will last us for almost the entire course. Of these 2 forces here, which ones are acting on the box?
Force two, yeah.
All right, so we have a weight acting which way on the box?
Yeah.
So what I do is I draw an arrow down on the box, and I put a little W right there to indicate that there's weight. If you want to do F sub G, go for it, but I'm going to be doing W here. Forces come in pairs, so that means I have a second weight vector, and that'll be acting up on the ground. So in terms of what I've written up here, direction of the forces with respect to its pair, they're pointing towards each other. With respect to with respect to the object, it is pointing towards the center of the other object. And the force on the Earth is pointing towards the center of the other object. Normal force. Any normal force between the box and the ground.
No,
Why not?
because there's no contact.
That's a key thing there. Number of students who want to throw normal force in every single problem. Please don't. Requires contact. What we have done here is the very first force diagram. We're slowly leading towards, that's probably next Thursday, we will get to a test-like problem. And I can guarantee, when I say test-like problem, there will be one similar to that in complexity.